So now the next problem is find the product of 8x cubed y over 2xy squared times 7x to the power of 4y cubed over 4y. So I have here a list of the steps in multiplying rational functions. So the first step will be factor. So we want to factor out the given expression. So let's write them as one rational expression. First, remember when we are multiplying rational functions, we would just go straight. So we multiply our numerators and we multiply our denominators. So we have here 8x cubed y times 7x to the power 4 y cubed 2x y squared, multiply that 4y. Now, to factor out, when I say factor out, for um, both numerators and denominators, we want to factor out by using prime factorization. When you say prime factorization, you it's like slicing out the cake until the factors, okay, has only two factor, one in itself. Let's say, for example, so we will begin by factoring out or getting the prime factorization of the coefficients. Let's start by factoring out 8. The prime factorization of 8 is 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. Now, I did not write here 4 because 4 has another factor. So meaning 4 is not a prime number. The factors of 4 are 1, 2, and 4. It's 1 times 4 and then 2 times 2. While 2, it has only two factors, 1 in itself, 1 times 2. Okay, now let's factor out 7. So the factors of 7, and 7 is a prime number, so you would just write there 7. Now factor out same thing, the x and y's. So x cubed is x times x times x. For the y, that's y. For x to the power of 4, that's x times x 4 times. And then y 3 times. Now for the denominator, we'll be doing the same thing. Let's start with the coefficients. So 2 is a prime number now, so you would write there 2. 4, we can factor that out. 2 times 2, because 4 is not a prime number. Factor out x, give us x, then y squared is y times y, then y here. Okay. Now, by the way, this is the long method. After the long method, I'll show you the shortcut. And next will be step 2, divide out. So we want to divide out common factors. Okay. So these 2 cancels out, cancels out, cancels out. X cancel out. This y here, that y, and that y, and then this y in here. Now let's write the simplified form. The simplified form is 7. So we only have one coefficient on top, which is 7 for the letters. So x here, so we would count our x's. 1, 2, 3, 4, 5, 6. So we have x to the power of 6. Then y, we only have 1. For the denominator, everything is cancelled out. So now that is our simplified form. Now what's a shortcut? The shortcut is actually can be, or you can actually simplify from here. Now, if you're having hard time canceling out coefficients, I suggest you do this part, the prime factorization. Now for the letters, it will be easy. Remember, if you're multiplying variables, you would add the coefficients, okay? Rule of exponents, rule of exponents, you would add the exponents or the degrees. So x cubed, x to the 4, we're multiplying, so that equals to x to the power of 7. Then y's, we're multiplying, so we would add 3, and then we have an imaginary number here, which is 1, so that's y to the power of 4. So I'm giving you another shortcut. So 8 times 7 is actually 56. And then let's do the letters. So x, we only have one x there. Then y, 2 plus 1, so that's y cubed. Then here 2 times 4 is 8. So this is now the shortcut. Do the coefficients first. 56 divided by 8, that will give us 7. Now 7, and then you have your imaginary number. Remember, if you are dividing exponents, okay, rules of exponents, when you're dividing, we would subtract the degrees. The 7 minus 1 will give us 6. And then y, so 4 minus 3 would give us 1. So that's y. We don't write 1. So that's the shortcut. Okay. Now, for the excluded value, we would be using the same method with the first example. So we have here the original expression and then here the simplified expression. Now look at the simplified expression. It doesn't have a denominator. Actually, it has, but it's 1. Okay, so since it's 1, okay, so we don't have a variable or denominator, meaning the excluded value of the simplified expression is none. So we don't have an excluded value. Now for the original expression, which is this part here. So this is our original expression. To check or to find the excluded value, you would go to the simplified or to the factored form over here. Okay, that's our factored form. So if you try to see, we have two letters, x and y's. Okay, since you have here two letters, you would equate them to 0. So we have x equals 0, then y equals 0. You don't need to solve for your x and y because it's already equated zeros. So meaning the excluded values now will be 0 for x and 0 as well with y. There you go.